So tonight we're here to talk about Dom. Dom's going to talk to us. That's right.
Leave if you want to talk about me.
No, not at all. No need. But a couple housekeeping things first, as always, and we have 7 or so people, I think, online as well on the remote, on the Zoom link. First of all, thanks to Ramona, who's not here. We usually shout out thanks to Ramona, but Nevada County Media, this is an awesome place. If you guys don't know that, I think a few of you, many of you probably know about this place, but they do a great thing for our community, and we're thankful to be able to do our meetings here. Upcoming events, shout out to Cindy Zulsdorf, our secretary treasurer, who's really done an awesome job organizing all these upcoming meetings as well as this one tonight. So coming up April, many of us will be in Vegas. Woohoo. We're talking about hotels earlier. That's always fun. Coming up in April. So no meeting next month. And then May 20th and June 25th, we have other meetings. Wednesday, Thursday. Hope you don't mind that switching days, but that's when things and people are available. Steve Holmes talking about hybrid facilities and PTP, which will be interesting, from Leader. And then Claudia from ASG coming up to talk about, hopefully she'll be in person for a DMF. So stay tuned for those. You are obviously all on the email list and get those emails, so you'll get those. The recordings from all of these are on our YouTube channel, and that is the QR code to go there, but you can find it. If you can remember this tiny URL I made for this, but go to YouTube, look for SMPTE Sacramento, or on the SMPTE site, you'll find these as well. And they go back a number of years, so you can go back and see lots and lots of those if you have nothing better to do. Tonight's show will be up there in a week or so, hopefully less than that, just so you know, we'll be there. Tonight also, you can ask some questions. I'll try to man the chat and things like that. So if you're remote, we'll try to ask some questions. We should have your audio if you want to come up and speak on camera as well. We should have that as well here. For anybody live, of course, just raise your hand. So I think most everybody here knows Dominic already, or Dom. The bio here from the website kind of capsulizes everything, but I think a couple notable things. There's like 12 years at Telestream,
Yeah.
Long time there. So obviously that's where people here know you from, for sure. And you are an actual working engineer. So
At one point.
not as much anymore, huh? But I think this is going to be a lively talk tonight, and I'm not going to read through the bio here as well, but he comes to us with a lot of good cred and background, and this should be an interesting discussion. So thank you, Dom.
Thank you, John. Thank you. Hi there. Nice to see everybody, and hello to everyone online. Thank you for dialing in. Aging myself.
Yeah.
I'm going to talk a little bit about some aspects of automated transformation and restoration of primarily video content, but we'll touch a little bit on some of the other things that go alongside it. I'll talk a little bit about why we care, what are the business needs. I'll talk a little bit about my kind of model of the process and deep dive a little bit further, particularly into the area of frame rate conversion, because it's kind of interesting if you like that kind of thing. And because it's 2026, I have to talk about AI. So I'll talk about AI a little bit at the end. By the way, full disclosure, Claude did help quite significantly in the layout of the slide deck and the presentation, because it turns out Claude's a better designer than I am. So, but if there are any mistakes, they're Claude's. So let's talk about the business need. Why do we need to do the kind of processes I'm going to talk about? Well, back in the day, you know what, I should start a timer just so I know how long I'm rambling on for. Excuse me.
Oh, talk as long as you want. Come on.
All right. There's only 138 slides, so it shouldn't take too long. Back in the day, you made a movie and you distributed it to movie theaters, and you made a TV show and you broadcast it on your network, and then it went into an archive and you were kind of done. Then, you know, people started selling TV content into different geographies, and the VHS tape was born, and then we had disc, and then we had streaming, and OTT and social media and YouTube. So suddenly all of the places you can potentially sell your content to, the number of endpoints has exploded. And so 10 to 30 or more versions of a piece of content for different geographies and different distribution methods and so on is absolutely the norm now. And then not only is there new content, but there's also all of this library of old content floating out there. And so long as it's not too expensive to get it to people, somebody's going to want to watch most things from the archive because they watched it when they were a kid or whatever. So there's this, so long as I say, so long as the cost of getting it to consumers is low, you can monetize these archives, even if they're kind of niche. One thing it's also, I think, really important to understand is we have just come out of, in my opinion, 15 years of a golden age of particularly episodic content production, because the streaming wars involved everybody spending like drunken sailors, and the chickens have come home to roost and they're not spending money on content. They can't spend money on content anymore like they did for Game of Thrones or Orange is the New Black or all of these huge flagship productions. And so that means that older content suddenly becomes more interesting and valuable. And again, as we talk about things like fast channels and so on, again, there's this insatiable demand for content. But it has to look decent.
Would you mind explaining fast?
Fast, free ad-supported streaming television, I think is the acronym. And essentially, the idea of a fast channel is that it's a linear channel. It's not on demand. It just throws content and advertising at you in a linear stream, just like good old-fashioned television. You don't get a choice, but it's delivered over the internet, and people actually like it. So long as the ad frequency is not too insane. Fast movies are horrendously painful to watch, but a lot of people watch things like local news on fast quite commonly. 3 years ago, people were saying it was going to save the media industry, and that's rubbish. But it's a nice little revenue source for some people. All right, so we need to do these processes. We also need to automate them. If you're restoring X-Files or Friends, you can spend $1 million an episode. That's great. If it's old 1980s sitcom content or telenovelas or you name it, you can't spend $100 an episode. So you've got to find ways to make the stuff look good in an automated fashion. And some of the processes that we're talking about, particularly frame rate conversion, you can't manually do a frame rate conversion. There's millions and millions of calculations that need to get done to do the job well. You can manually remove noises and scratches and so on if you want to from content and repaint frames and so on. But there are some things you just can't do without a computer, or can't do well. So let's talk about the process. And I would, for the purposes of today, define it into 3 stages. The first is what I refer to as a clean progressive source. You take whatever crap is coming in and you make it the best that you can in its original format. So its original frame rate, its original resolution, and so on. You try and eliminate as much of the garbage in, garbage out problem as you can to start with.
Does that mean converting interlace?
Sorry?
Does that mean converting interlace to progressive?
Absolutely. You can do almost nothing with interlaced content. So you have to go to progressive. And then you have a whole set of transformations to get the video to the output format that you want. And because I'm a video guy, that's what I'll focus on. But there's an awful lot of stuff you may need to do to things like, well, certainly audio, captions, subtitles, other metadata, audio description. There's no end of other stuff that you may need to futz with to get it to the distribution channel you need. So those are the ancillary conversions. So step one, make a clean progressive source. So everyone knows what interlacing is, right? God, you're all old.
Well, the only guy who may not.
I don't.
You don't?
Ooh, be honest.
No, it's all good. It's fine.
Yeah.
And anyone who does should just be able to turn around and tell you it's a pain in the ass, and it
Yeah.
always has been.
Yeah.
Right? But it's
Fine.
essentially old analog RF TV would send alternate lines, right? You'd send even lines followed by odd lines followed by even lines, and effectively it was quite an effective means of 2-to-1 data compression. But unfortunately, when we stored those images in a digital form, we composited them together into a single frame that had odd and even fields that were at different time points. So nothing lines up when things move, and you get these combing effects, which you'll see in a minute. Sort of corollary of that was, rather than interlace camera shot on content shot on a TV camera, if you shot a movie, those frames were progressive and they were shot at 24 frames per second, but you then did this thing called a 3:2 pull down, which turned it to 2997 or 30 frames a second by having some fields repeated and some not. So you got 2 interlaced frames, then a progressive frame, and then 1 interlaced frame and a progressive frame, or I can't remember off the top of my head. I used to be able to recite pull down patterns, but I can't anymore. And you have to get rid of that. And then you have to get rid of noise. And noise, for the purposes of this discussion, could be from a film scanner, it could be noise from an old noisy digital sensor, it could be dust or scratches, it could be noise from multiple generations of tape, you name it. But also critically, if it's film originated content, even though your filmic look is important, you do need to get rid of the film grain before you do anything with it. And generally speaking, you probably want to put it back afterwards. And I won't really go into that, but it's worth noting that you can't take well, you can, but some people would not like it if you took film originated content and made it look like a soap opera. Anyway, picture speaks 1,000 words. So here's a picture to try and illustrate the process. Anyone recognize the show? No? 21 Jump Street. So some people might want to watch a young Johnny Depp, not me, but some people might. There is value in it. So here is this was shot on 16mm film, 24 frames a second. So these combing artifacts are from a pull down pattern, not from true interlacing. But obviously it's ugly. There's also a bunch of noise in there, which you really can't tell. So we'll close in on the interlacing patterns a bit more, and you can see all these combing lines here. And when we reverse the pull down pattern, this is what we get: a nice cleaner progressive image. Obviously there's a bunch of motion blur and stuff, but that's wanted. And then we have to take noise. This is all some scanner noise and some film texture in here, and we want to get rid of all of that, which is that image on the right there. So we go from this to this. I don't know how well this comes across on Zoom, so I apologize, but I hope you can see it a bit. So then once we have our clean progressive source, we have all of these things we may want to do with it. Convert the frame rate, convert the run length, convert the dynamic range to HDR. We probably want to change the resolution and the aspect ratio, and usually right at the end, if we're going to an interlace target, we need to re-interlace. So let's talk a little bit more about frame rate conversion. And I've mentioned re-interlacing on here because even though it's the last thing you generally do, it kind of sits with frame rate conversion. So we still live in a multi-frame rate world. You could make a very strong argument that that will almost completely go away, and I think it will, because every TV, LCD, flat panel display can display everything from 24 frames up to 120, 240, you name it, right? So why on earth would you try and do frame rate conversions? Why wouldn't you send native frame rate to the TV? And that is, in fact, what streaming services tend to do if they can now. But what you really don't want is the TV doing a frame rate conversion, because they really screw things up. So some people still prefer to control, and particularly if you've got content that was originated at film frame rate and it's not at film frame rate, you probably want to convert it back to film frame rate by doing a pull down removal and so on before you put it onto your streaming service. But the need for frame rate conversion will slowly dwindle. There've always been some simple-ish methods of doing it. You can drop frames, you can duplicate frames, but that causes all sorts of issues in fast motion where things, like particularly you'll see it in pans where things stutter. You can do frame blending, which again can look okay at full speed, can cause weird ghosting and haloing effects, and looks awful if you hit pause or you want to do a freeze frame or something like that. So the real way forward is what we call motion compensated interpolation, where we're actually synthesizing frames, and I'll talk a little bit more about that. And just to go back to the interlacing piece, if I want to create interlace content, I have to create progressive content at twice the frame rate of my final output, and then decimate every other field in every other frame, and make sure I do all my vertical low pass filtering to get myself below the Nyquist limit. Otherwise I get all sorts of nasty jittery artifacts on the right kind of content. Vertical patterns look horrible if you get it wrong. Okay, so we have to make new frames where they didn't exist. That we have to make new frames where the camera didn't take a picture. So, you know, the blue frames across the top are the original ones. These were actually taken by the camera. These orange frames at the bottom are at points in time where the camera didn't take a picture. So how do you do that? Yeah.
Maybe go back. Is that there's motion occurring frame to frame to frame to frame.
I'm going there, Bob. So yeah, so let's take a simple example, right? I have a frame, it's got some things in it, those things are moving. So, you know, my circle from this one frame A to frame B, and my source has gone from left to right, my triangle's gone from top to bottom, my arrow's rotated, and now I have to create this frame in the middle somewhere with everything in the right place. So I have to move everything around. But things move at different speeds, things move in different directions, foregrounds and backgrounds move in different directions, objects overlap, they occlude, they reveal, rotation, flags waving in the breeze, non-rigid deformations, all of these things trick you and trip you up and make it very, very challenging to do in a way that it looks good. And it's very interesting looking at what people will pick up on and what they won't. There are some really egregious artifacts that people will just not see. But if you freeze frame them and do frame by frame comparisons, you'll see them. And then there are some absolutely minuscule things which people will zoom in on no end. So again, we can break this down into some processes. First thing we have to do is detect where all the scene cuts are, transitions, fades, things like that, because I don't want to be estimating motion across a scene cut. Because if I know there's a scene cut there, I know nothing moving on this side of the scene cut is going to be on this side of the scene cut. It's an assumption, a safe assumption to make. Then I have to do lots of different motion analysis in my different scenes and produce motion vector fields, forward and reverse motion vectors for every pixel or sometimes every sub-pixel to work out where it's going. I then have to score those motion vectors because we will get them wrong. So you will do multiple different motion vector searches and, score the different motion vector fields and pick the motion vectors that you think are the most likely candidates. Generally speaking, we'll have to pick up a bunch of the special cases, things like strobing, rotating objects, you name it, that kind of stuff. And then we actually have to make new pictures. And then potentially at the end, if we're reducing frame rate, we have to add motion blur. I think I'll talk a little bit more about that later. So I've talked about scene cut detection. Motion vectors, there are a bunch of different techniques. There's spatial block and pixel-based matching. We do that generally in a hierarchical way. So we'll subsample the image and do gross motion searches and then go to finer and finer levels of detail. And then we'll refine that with techniques called frequency domain phase correlations, which I won't go into. And eventually, through all of these different processes, we come up with a motion vector field or a set of motion vector fields. And it's worth mentioning that the kind of motion search that you would do in a video compression algorithm doesn't cut it here. We are going into a far greater level of detail, and the penalties for getting it wrong are far worse doing motion compensation than they would be in compression. If it's compression, you've just basically reduced your compression ratio a bit or your compression efficiency a bit, and you can account for that in other bits of the algorithm. With this, there's kind of nowhere to hide. So then again, as I said, we're scoring motion vectors and accounting for special cases. So scoring techniques include forward and reverse extrapolation. So I've got my image here, I've got my motion vectors. Well, it makes sense to try and use these motion vectors to regenerate the next image that actually existed in the sequence and the previous image that actually existed in the sequence and see how well they match. Because if it matches perfectly, then I'm pretty sure my motion vectors are really good. And if it doesn't match at all, then I know something is horrendously wrong. We do spatial correlation, and temporal correlation, in fact. So we compare I've got a motion vector for a pixel and I compare it with the pixels around it, and I compare it with the pixels in the same region before in the previous image and the next image. And I do a bunch of scoring to say, I think this is good. But there's always things that catch you out, right? Single pixel moving in a different direction and it's really in the original image. And sometimes that's visible and sometimes it's not. So,
We used to do testing on film cross compartments. Certain things were hard to deal with the motion, and we had footage files of a race car driving by with stationary seats in the background with flags waving.
Yep.
So the combination of those three, if you could correct them all with your motion vectors, you were good.
That's a pretty classic torture test for a motion compensated system. Yeah. Anything like that, crowds in the background, something in the foreground, camera panning, flags always help. If you can get something spinning as well, just to really screw you up.
These are all reasons why you want to do that noise reduction early in the process. So you're not mapping and vectoring.
Noise isn't confusing things. Yeah, exactly. Because noise is inherently kind of uncorrelated, right, from frame to frame. And it just decreases the accuracy of your algorithms.
Which is more work, I would think, too.
Can do. Yeah. And this is why, again, even if you want your film look, you want to get rid of the film grain first and then resynthesize it later. That's one of the reasons. The other reason is that film grain doesn't scale. It looks weird when you scale it. And again, lots of special cases, occlusions, reveals, rotations, periodic repetitions, strobing, all of these things. And then you create new frames. You take all the pixels and you move them into the positions you think they're supposed to be in, and then you realize that there are bits of the image that you're trying to build that you don't have anything to put in, and you have to work out where you get that stuff from. And you can steal from spatially from pixels around it, or you can steal temporally from pixels before and after it, and you have to do that based on how much motion you think there is around. But at the end of the day, you can generally make a decent looking frame. And you always have to be particularly aware of boundary conditions, right? If I've got one area or one object where I've got really solid motion vectors, and then maybe it's a blurry crowd behind where my motion confidence is way lower, I have to be super careful about how I transition from that object, highly focused solid object where I've got really great motion vectors, into the crowd background. Otherwise I get all of these swirly boundary effects. And then, as I said, add motion blur. If you are going from high frame rate to low frame rate, particularly if you're going from 50 or 60p down to 24, and you do not motion blur, it will look terrible. It will look stuttery because 24 isn't really enough to convey true motion. And if you look at film content, it's very blurry because they use wide shutter angles, longer exposures, and that tricks you into thinking that you've got smooth motion. But if you down convert stuff, you can get really bad motion artifacts. And in fact, because people have been shooting movies at 48 frames for the last few years, we've seen some people who really should know better not doing this well and making 24 frame versions by dropping alternate frames. And it's one of the reasons why people have been very critical of 48 frame content, is because when you show it in a 24 frame theater, if you haven't done this right, it doesn't look great. So again, let's look at some pictures. So, and yes, it's race cars on the background.
Mustangs again, too.
Yes. And so here's my first source picture, and here's my second source picture, right? 1, 2, 1, 2. Now here's my source picture. This one is completely synthesized. And this is my second original. So source, synthesized, original. So the theory works. I think it looks, pretty good. Can anyone see an artifact? No? Come on. Yeah.
The sign got a little blurry.
This sign?
Yeah.
Maybe a little. So look here. So for those of you following along on Zoom, look at the leftmost fence post at the top where it curves in. Nice and clean. Much more blurry, nasty artifact, completely non-existent artifact there. And then, gone again in the next frame. And then if you look at the watch, the crown of the watch and the strap on the right-hand side, and this is a classic edge effect because we've got no motion searching beyond the edge of the image. There's nothing there. You'll see that the watch face moves and the strap doesn't, and the crown goes blurry for a little bit. But if you're watching this at full motion, you're not going to see it. You're not going to know. You're not going to care. And the alternative is this, a frame blend. And so I think generally speaking, the motion compensation is doing a much better job than simple frame blending. And then we have to do things like resolution change, SD to HD looks okay, HD to 4K looks okay. Frankly, SD to UHD or 4K with conventional methods doesn't look great. And this is where AI is really starting to win. We're definitely seeing that. There is always going to be a need for downscaling because people will tend to shoot at the highest resolution they possibly can to future-proof their content. And then, you know, I'm shooting 8K or bigger and I need to get it onto a TV. Well, I need to down-res it to at least 4K and possibly HD. Anyway, there's a lot of interesting, or if you like that kind of thing, interesting stuff around resizing and the different resizing techniques and the way you sharpen and all of that stuff and the way you eliminate ringing. Also, somebody did a SMPTE presentation at, I think it was at Miranda back in the day, and they were making hardware upsamplers, and they pointed out that there are strong cultural aspects in what you like in upsampling. You know, Asian upsamplers like really sharp images that ring and look horrendous to me, but they would look at our stuff and go, it's, you know, blurry and soft and so on. So there's a lot of taste that comes into play of what you think is good when you're getting into these kind of details. Aspect ratio conversion is really interesting these days because aspect ratio conversion used to be 16:9, 4:3, right? You letterbox, you pillar box, you do a bit of a stretch and so on. Now, most stuff is shot 16:9 or in a cinematic aspect ratio, but I've got to get it to 9:16 and I've got to get it to square. And if I'm making a movie promo, it's got graphics on or text, and I suddenly take my 16:9 frame and I want to get it to square, you know, I chop text off, and there's a whole bunch of, and I for one hate the thing where they massively zoom the image and then place the 9:16 image back on top of it to fit it into a 16. It's like, could we not think of something a little bit better? I mean, I think I almost just prefer a black matte rather than that, but whatever. So there's a bunch of like interesting problems in aspect ratio conversion now that we frankly didn't have 10 or 20 years ago. Run length and dynamic range conversions. So not every broadcaster or whatever has the same run length requirements. You know, a 30-minute show is never 30 minutes, but some places it's 27 and some places it's 24 or whatever else. So there's all sorts of reasons why you need to change the run length of a piece of content. And of course, North American broadcasts, guilty secret of make it 30 seconds shorter and stick another commercial in, right? Which is endemic. What's interesting about run length conversion is that you can use exactly the same motion compensated techniques to create a different number of frames in a piece of content. And if you leave the duration of the content the same, you're effectively changing the frame rate. If you leave the frame rate the same, you're effectively changing the duration. So we can make, with essentially the same calculation and maths and processes, we can choose to use it to make content a bit longer or a bit shorter in a very linear, smooth way.
You have to
Sorry.
get special licensing permission to alter the run length of a piece of material.
So that's a really interesting question. I think the answer is for things like TV, if you're commissioning the content, then you pretty much have carte blanche, but they don't like the producers to know. What is really interesting is when we talk about audio with that, because there are certain Hollywood talent, I believe Tom Cruise is one, but there's not the only one, where it is written into their contract that you will not change the pitch of their voice. And if you're doing like a linear compression and you choose just to speed up the audio, that changes the pitch by about a semitone if you're going, you know, or whatever. And it's contractually forbidden. Now, would they notice? I don't know. But it's a gray area. I mean, I think for first run, you know, primetime content, it does get done, but they obviously feel very comfortable that they're allowed to do it. And so on. Interesting question, though. And then increasingly these days, we have to think about HDR and SDR conversion. That's probably a whole talk in and of itself. And I'm probably not the best person to do it, but it's a pretty complicated area. Again, it's one where AI will predominate because it's one where the best way to do it today is with an artist, with a colorist, and we can basically train a neural net to be a colorist at this point. So, and even a specific colorist, you know, you could have a director build a neural, just as you can, you know, use a neural network to emulate an actor's voice. There's no reason why you can't have a neural net that emulates a colorist's look. And, you know, directors pay through the nose to get their colorists. And, you know, they love the look of particular colorists and so on. So it's another area where, you know, AI is going to change the world. So I touched on audio a bit. Obviously, there's, you know, if you're doing audio run length adjustment, you probably need to do audio pitch shift. You may need to do stereo to 5.1 or even 7.1. Converting flat sound fields into object audio is okay, but it could be done a lot better than certainly in automated terms. If you've got all your audio stems and you can remix the whole thing, you can do a nice job of it, but it's highly manual. But if all you've got is a piece of archive content with stereo, you can't really, you can kind of get it to 5.1 and it'll sound okay, but getting it beyond that is really tricky. Captions, subtitles, you know, if you're retiming, you need to change them to match. If you're resizing, they need to be visible if they're burnt in. And there's a whole load of stuff that you have to think about with that. And again, I'm not going to go into the detail. Yep, absolutely. Absolutely.
You sure you could touch a second on burned in subtitles? Like, what do you do? Press that part of the frame or?
What in subtitles?
What's that?
You said burnt in subtitles?
Burned in, like
Yeah.
not metadata, they're actually in the picture.
Yeah.
Very rare, I think.
It depends.
That's repurposed.
Well, I mean, no, but I mean, they are any static graphics that's been put on top of the video has its own set of challenges. And when you're doing things like motion compensated frame rate conversion, one of the other things you have to do, it's one of those kind of special cases, is find all the static graphics and kind of treat it differently with kid gloves so that you don't mess it up. But burned in subtitles are fairly unusual. More common in Asia. But AI. What does AI have in store? Well, AI essentially is going to replace most of what I have talked about in the next 5 years, I think. Neural super resolution is already good. Neural super resolution can create detail that did not exist. It can invent detail that did not exist in the original image. And usually, done well, that looks better than an upscale. Unless it's very particular content. where maybe you don't want to add additional detail, but you have the choice.
Who's offering tools like that? Is your company offering you?
We have a partnership with NVIDIA to offer some AI-based super res. Probably, honestly, the leader in the field is a little company called Topaz. And they started with stills photography 15 years ago, I think. And then they got really good at doing single image scaling. And then, in the days when, they might take, 10 or 15, 20 minutes to do a single image. Yeah. So it really was impractical for video, but now they're getting there with video as well. Anything that is done well by a human today, like the kind of detailed image restoration work that they did on X-Files or something, manually repainting and so on. AI is going to be able to do that. It just is. The only challenge is making the training sets that teach it. Frame rate conversion, yeah, we're getting there. It's not great, but it'll get there. Again, tone mapping, a robot colorist is entirely, on the cards. And of course, the intelligence to orchestrate all of this stuff, to look at content, work out what needs to be done, what other models need to get invoked, your supervising agent in AI terms, I guess, that where you just say, I need to take this content and make it into this, and it works out what needs to be done and then invokes all the other tools that do it. And, we just sit on the beach drinking margaritas or something. One interesting thing for me about this, talking about the business that I'm in, and the software business in general, has this problem and has had it for some years, but we've got all of this IP that's baked into commercial software products. I don't go and write academic papers about my algorithms. I don't publish my algorithms because I don't want anyone else to know what we're doing, because it's taken us 15 years to build them. But when AI takes over and, my current product range goes obsolete, do we care that knowledge has gone about how to do that? There was an interesting situation a few years ago now where somebody discovered an Amiga hard drive. And what was interesting about this Amiga hard drive was that it used to be owned by Andy Warhol. And it had a bunch of Amiga graphics files on it, which people assumed were Warhol originals. But nobody could read them. There wasn't a machine around that could read them. There was no documentation on the file format. And they actually did a open source, crowdsourced project, and they treated it like a code breaking exercise. And they reverse engineered the format and got the pictures out. But it took a lot of effort. Now, of course, I suppose Claude could do that in 15 minutes, but so maybe we don't need it.
What's Amiga?
Very old computer.
Oh, have you ever heard of Amiga?
I actually have.
Yeah, Amiga. Yeah. Anyway, so it's a question, should we be concerned? There are potential mitigation strategies, if anybody wants to adopt them, but, I think maybe there are things like software products that should get put in code escrow and at some point 50 years later released to the world or whatever. But question?
No.
Okay. All right. Well, that was it. Yeah.
So back in the day when I was a little more active in the business, there was a paranoia about open source software and the licensing techniques. So when you talk about areas like this, how has the work of the world evolved and the attitude towards using open source models inside of your own software algorithms.
Is the world still
Very wary of using open source with the wrong licensing.
With the wrong licensing is the key.
Yes.
But there's some really interesting pieces to this, right? If I, as I do, among other things, run a full-on SaaS platform running on AWS, I can use any open source code I like because I'm not selling it. I'm selling a service. I'm not selling a piece of software. But if I take that same software stack, as I happen to do, and sell it as a product, if it hasn't got the right license, then in theory, I render my entire code base open source with the full GPL license. So I don't use it. But then the other question is, who's going to know? Who's got the resources to sue you anyway? ProRes, Apple ProRes has been in FFmpeg for donkey's years. Apple have never done anything about it. They don't seem to care. There's bugs in the FFmpeg implementation as well. Not huge, but small ones. And, you know, Apple don't care. Cindy.
Oh, I just want to address, Ray, what you were saying. I mean, if we think about sort of related on open source, if we think about the media exchange layer, and then that's really a Linux Foundation open source thing, and what's happening with dynamic media facilities, which is all people contributing to it. There is that movement in the industry toward open source, and I just thought I'd tack that on.
I mean,
I mean, there are groups that are very, very pro open source.
And, you know,
I've been from the user, the EDU.
But
manufacturers in this room are participating in that DMF stuff right now in MXL, and those are all open source.
And, you know, I've been doing transcoding for quite a long time, and I know that an enormous amount of the professional transcoding, the content you watch goes through FFmpeg multiple times, and no one cares.
No, it depends which French company owns you as to how much they care. Because we pulled out. So I was with Grass Valley Group. Went through the whole Thompson thing, and they were paranoid about open source and licensing because they've made, I think it was like 20% of their revenue came from licensing, 25%.
Yeah.
And I think it was 500 million a year they made out of licensing.
Yeah.
And they did not want to risk any of that. And they forced us to pull out of what was Brad's earlier effort.
Yeah,
we had to pull out
now
of
the AMWA, but prior to that,
maybe it was that one. AAF or something.
Yeah.
Because of the licensing.
But they're back now.
But it's not Thompson anymore.
Correct.
Right.
Correct.
The French were absolutely paranoid.
Oh my gosh.
Yeah.
We looked at it and said, we will get more than we give.
Yeah.
Every time. But because of the licensing knockoff to things that might be built into a bigger license, like the compression algorithms, they did not want to risk it. It sucked.
Just for reasons that'll go unmentioned, my wife and I watched the 1963 movie Cleopatra a few days ago. And it was one of the big blockbusters. It was gorgeously filmed. And obviously, Apple or whoever converted it had access to the original, probably the film negatives. But the video was astoundingly good. The audio totally, completely sucked. What is being done to address issues like that? Because I know that the audio, the sophistication of audio in 1963 was not that good. It was probably just recorded as a stereo track with nothing to work with.
Yeah. What is being done? That's a great question. And, you know, I couldn't say I'm necessarily well qualified to answer it. I mean, I am sure I mean, there are definitely some interesting AI upmixers. There's some really interesting AI audio separation technologies where in theory you can take a mix like that and take it back to audio stems, literally to potentially the individual instruments of the orchestra, and then remix the whole thing. So and certainly you can extract the dialogue tracks and things really pretty well. And maybe you just put an orchestra in the studio and redo the score and then put the dialogue back on top. You know, there's all sorts of techniques.
So I was a little shocked and disappointed that they didn't at least do some dialogue isolation because it was bad.
It's also really dependent on your listening environment. The mix that you need for a good 5.1 living room environment compared to the mix you need for an in-flight is so different that having the same mix and expecting them to serve both ends is really not going to work. Yeah, Dean.
Quick comment on that. That might just be original picture and original audio.
Yeah.
Like the agreement was to broadcast the best original representation.
Right.
In 1963, the audio was probably pretty poor.
Yeah. And I really suspect that that's the case. But
Licensing, overdriven.
Yeah.
But I have an imaging question I wanted to jump out there. Fantastically, right? This thought process. People are shooting in 8K, 4K, most expensive RAW cameras they can find to future-proof their content. When it hits my screen, it's been through scads of comp cycles, computer cycles to modify it. So that original content is not even what I see, right? The fact that it's pixels is just because that's handy, right? My device shows pixels. So the question to you is, in all your years, should we be capturing something else? Should we be capturing more information from this stage, motion information, layers and depth maps and all that kind of stuff? So you're not just capturing this static picture field that you then have to run through, you know, a billion data centers worth of, you know, information to get it on my phone. So it's just like, what do we mean by original video?
Well,
you know,
yeah. And
anyway, so to you, like, what do you think about that?
What people sometimes refer to as object-based video has been sort of the holy grail for 25 years, right? The idea that we stop representing pictures as dots and represent them as models of things. It's the difference between a JPEG and a scalable vector graphics image, right? And if you can turn everything into a modeled object, then you have a bunch of different things you can do. And yes, you might as well start thinking about having your models exist in 3D space and then rendering a 2D rendering from your basic, which when you think about it is actually how something like Unreal works, right?
Sure.
It builds a 3D model of its universe. And then if you're using it to make a movie, you end up taking a flat 2D projection.
Instead of, I mean, a frame of pixels is already a highly compressed piece of information of the scene, right? I mean, the scene itself, the first picture you take of it is already super compressed.
The flip side to that is how much data do you really need to take of some of this stuff?
Well, 10 years ago, we would have said how many cycles of computer time does it take to process one frame with motion vectors? Right? It was like,
but I mean, we can bloat the world with all this content, all of this data that we're probably never going to use as well. So, it's like, I mean, it's a legitimate question. Should we be thinking about keeping source code, or should we just let it float down the river? And the answer is probably a bit of each. Sorry, was there another? Sean.
Comment and then a question. I think you're going to end up with some of the same interpolation issues, even if you've got depth information. If you've just got 2 or 3 cameras, right, or depth detection devices, you're going to have holes where there's no depth. So if you want to move in 3D space, you still have to you have to make stuff up, right? and you also need standards.
Yeah.
I don't know where Cindy is on that. My question is there anything special or tricky that you need to do if you're doing this processing on 3D video? Can you just do the left eye and the right eye separately and end up with a good result? Or are there things that are extra expensive because there are two that are correlated? Or can you cheat and save on the processing because they're correlated in some cases?
The only 3D video workflows I have encountered have been 1920 by 1080 side by sides. So you've got 960 or whatever it is by 1080 images side by side in a single frame. And for something like frame rate conversion, I think we just frame rate converted it and it was okay because it was relatively low resolution. So I mean, for just classic kind of 3D,
Right left side by
Side
side
in a frame.
yeah, and that's pretty standard way of moving 3D around because everybody knows how to deal with 1920 by 1080 content. So just splitting it into two and using, basically compressing it horizontally has been a common way of doing it. And frankly, it doesn't happen much because most of that stuff was always just 24 frame cinematic anyway. But no, the little of it I know about, it's been okay, partly because it's probably quite low resolution and partly because, even in that stuff, most of the scene isn't actually 3D, right? Because your 3D perception's only about 12 feet. Your binocular perception's not huge, right? It's only the first sort of 12 feet of your field of view. Beyond that, everything's done on context, which is why they let you drive if you have one eye, because you don't actually need stereo vision for most of your depth perception. So
Just when you run into the guy on your hood.
yeah, exactly.
Who's that? I'll do that.
Yeah.
Can you talk about the economics of this in like terms of like flops per frame or minute of video converted in dollars per minute of video converted? Like what's economical and what's a reasonable amount of computation power to spend on?
Not perhaps in quite those terms, but Cinnafilm, we do all of our number crunching on a GPU, and a relatively modest sort of $600-700 gaming GPU would give you better than real-time performance at HD for doing a motion compensated frame rate conversion. Use a G4DN 2X large in AWS, and it's got more than enough grunt to do UHD at real time. And I don't know the price, but it's pennies an hour. So the compute cost and associated energy costs and so on is yes, pretty cost effective at this point. In fact, when we're doing big files in AWS, it costs us more for the local machine storage than the computer itself. Because local hard drives on EC2 instances are expensive, but then compute's dirt cheap. And of course the egress cost puts everything into shadow. But yes, sir.
When you were talking about object-based video,
Mhm.
do you mean video like literally as a collection of objects in a 3D space?
Yeah, a virtualized collection of objects in a 3D space. Yeah, exactly. Yeah.
So would all this conversion and compression be done through like shaders? Or how is it done in that situation?
Well, I mean, I don't know how things like Unreal and so on work. The point really was that potentially the ultimate way of representing video is not as a set of pixels, not as a set of dots. It's as a set of objects,
Right.
that are much more complicated. But I mean, people have been experimenting with it for decades, literally, but it's never got to a point where it's viable. And people have talked about this as a way of doing incredibly efficient video compression and so on. But it looks like that's probably a dead end, because the next generation of video compression is going to be generative neural networks, where you send network weights rather than picture, and stimulating functions rather than pictures themselves, or at least so I hear.
Was not JPEG 2000 or something originally intended to be object based or something?
There was a version of MPEG 4 or MPEG 7, maybe MPEG 7.
There was an MPEG version that tried it.
But yeah,
Yes,
but they
I
could
forgot
really,
about that.
they did graphical objects really well, but in the real world, it was just a
What was the special thing about JPEG 2000?
JPEG 2000 uses wavelet compression
Wavelet
instead of DCT based algorithms.
It's
very good at layering.
Different rasters.
Yeah.
It's supposedly unencumbered by as many patents as
It is.
as any DCT based algorithm. And it's fast now.
It is fast.
High throughput JPEG 2K is amazing. If they'd thought of it 20 years ago, it would have really changed things, but they didn't. So
The same two guys.
yeah.
I have an AI question. I mean,
I will try and answer. I wouldn't claim to be an AI expert.
mine is a quad.
Yeah.
Brilliant work, team. So the question about I'm assuming you could train an AI to do this, but would they have to be trained literally on your software stack to be as good as you? Number one. So how did they get so good in the first place if they weren't just open source?
Well,
sophisticated.
there's
two parts.
Yeah. Okay.
Put them together.
Okay.
The second part is, couldn't the answer to your final question, can we just throw away the software then? Can we just ask that same model? I'd like a C++ 98 version of what you're doing.
Yes.
Okay, those are the two questions.
So question one. Sorry, remind me of question one.
AI can self-learn and train and things like that. But if they're going to be as good at it as Cinnafilm, do they have to train on your software?
Well, if they train on my software, they can be almost as good as my software. Or maybe slightly better. And interestingly, I was involved in a project some years ago to recreate a massively computationally expensive image processing algorithm with a neural net. We just literally took the input and the output and taught the people I was working with, not me, taught a neural net to do it. And we got it from a 40 server farm to a single workstation with a single GPU with almost the same results.
So what it's doing inside could be completely different.
Oh, completely different. Nobody knows. It's a black box. The thing that's interesting about doing stuff like frame rate conversion, potentially it can do a really perfect job, but you've got to work out how to give it the right training data, right? And,
So you're not training it on the technique, you're training on an input and output.
So I've got to have perfect video at two different frame rates to train it. Well, how do I get the same piece of video that's utterly perfect at two different frame rates? Well, yeah, but then it learns how to do animation really well and it can't do live action really well. So yeah, there's all sorts of bits that you can do. And I am sure that the AI guys have a whole bunch of answers about how you do this kind of stuff. And I don't know what they are, but it's a really interesting question of fundamentally, you can't have the identical piece of video perfect at two different frame rates. you have to futz something. You have to do a really high frame rate rendition and then do different sets of frame composites. You know, if you start with like 1200 frames a second or something, and then composite different sets of frames to simulate, then you're getting there. Or maybe you can read a sensor at different points in time, or you know, there's all sorts of clever things I'm sure that they can do, and they are getting there. I mean, let's not be, you know, they really are. They're not there yet with frame rate conversion. They're very close with image scaling, because partly it's quite easy to take a big image, then reduce its resolution, and then blow it back up and see how close you are to the original. So image scaling is pretty easy to build a training set. Frame rate conversion is harder, but they, you know, they do it.
I think what I get lost on sometimes is the model is trained on
an in and an out,
Mhm.
not on a method.
Yes.
Like, take this
Yes.
thing, compare it to that thing, and you go figure out.
Yeah, and you have no idea at the end what it figured out.
I have done some C++ with it, and I agree. I
Yeah.
have no idea what it's done.
There was a lovely story years and years ago where somebody got a very early neural net or possibly a genetic algorithm to design an FPGA. It worked beautifully. And then they went and looked at it and realized there was a whole section that was not connected to anything else. But when they took it away, it stopped working. Yeah. Yeah. It will find ways to do things that will surprise you when you, yeah.
I asked our remote crowd if they had any questions, and nobody came up. Nobody spoke up. So
Okay.
anybody else here? Awesome. Thank you,
Well,
Tom.
thank you, everybody.